we've got this imperfect test. By that I mean typically that the sensitivity is not equal to 1 and or the specificity is not equal to 1. Now, very often we would like to measure the prevalence of a disease in a particular setting. For example, what public health measures one takes might be dependent upon the prevalence. So, for example, if we are concerned about schistosomiasis, then what the WHO prescribes as treatment depends very much on what the prevalence of the disease is. So we'd love to be able to measure prevalence. Unfortunately, we might have an imperfect test. So what do we do? So let's continue with our example where we had a population of 1 million and 93 we said actually have the TB, but 28,565 tested positive. Do we estimate the prevalence by taking 28,565 and dividing by 1,000? That is what we would do if we had a perfect test. We would just take a look at who tested positive and divide by the number tested, and that would be our estimate of the prevalence. Now, clearly, we would be way off here. Instead of 93, we've got 28,565. So we're off by a factor of what, 300 or something like that. That is not the best thing we can do. So what can we do? Well, what's the problem? The problem is looking above the line, which we don't know, but the problem is that we would love to have both 68 plus the 25, but we would love to take out these 28,497 that we got who were false positives. So we would like to replace the false negatives, bring them back into the fold, and get rid of these guys, get them out of the fold. So that's what we would love to do from the 28,565. So we are going to find these guys in here, and we're going to find these guys in there. All right? And if we do that, if we look at the 28,565, subtract the 28,497, add the 25, we'll be back to our 93, which is our true prevalence. Okay? So how do we figure out what this one we observe, so that's no problem, but how about these two? How do we get those? Well, how did we get those in our calculation? These guys were of those who did not have the disease, so that's 1 minus the prevalence times 1 million. How many tested positive? That proportion should be 1 minus the specificity. Okay, so now we know how to get this guy, because we just look at 1 minus the prevalence times 1 minus the specificity times 1 million, and that gives us that guy. How about this guy? Well, very similar thinking tells us that this guy was the ones who had the disease. That gives us the prevalence times 1 million, times 1 minus the sensitivity. Sensitivity was the proportion who tested correctly. 1 minus the sensitivity is going to give us the proportion who tested incorrectly of those with the disease. So there we have it. Now divide through by 1 million, and what do we have? We have that when you bring the million over to this side, divide the 93 by 1 million, and that gives us the prevalence, 93 per million. Divide the 28,565 by 1 million. You get that. Solve everything. And what is that? That is the proportion who tested positive. And so there's the formula. The formula is you estimate the prevalence by looking at the proportion who test positive minus 1 minus the specificity divided by the sensitivity minus 1 minus the specificity. And that will give us our 93 per million in this example. In general, this is what we do to accommodate imperfect tests.